I'm going to get started in just a second, guys. Let's just wait just a second. Okay, it's Thursday. So Thursday means lab day. We'll be working through lab 3 here. And so go to Brightspace, open up lab 3 and get that started. And then you'll be using your Raspberry Pi. So you'll have to see how you want to do this. Eventually, you'll probably want to be booting up your Raspberry Pi and opening up the lab on your Raspberry Pi and editing it on Pi there. There. For now, if you want, I'll have it up here and you can look at it and then you can go do stuff on your Pi. Again, you want to be probably sharing the keyboard and mouse and the screen between your Raspberry Pi and your Windows terminal. So you have to kind of decide how to do it. Like I say, I think it's probably going to be best if you can get the Raspberry Pi, boot it up, connect it all up and boot it up, and then open up the lab in a web browser on your Raspberry Pi. So I'm going to show you how to do that in just a sec. But so as you're going through and doing this now, I'll just walk through the lab real quickly. First part is talking about this GPIO. These are these pins, and we have those connected to our breadboard here. It talks about a couple of, some of them are 5, provides power, 5 volts. Some of them provide a little less, 3.3 volts here and here. For everything we do, you can use either of those. A lot of them, and there are a number of ground pins here that we can use. But again, usually we will have ground and power over on the left side, this area here that is connected here. But again, these will be labeled, and often your T adapter will have these labeled for you here. There's a number of what we call general purpose I/O pins, GPIO pins here, and we can use those to programming. They're kind of a weird number system, but we can use those, and we'll often plug in a pin into one of these, and then we'll control this in software. There's some special purpose I/O stuff for certain things. We generally won't be using those. Those are often, they can be used as special purpose or general purpose stuff there. The first thing is to redo the lab you did basically last time, where you had an LED light up without any, it was always on there. So that's the first thing to do, is recreate the lab from last week where the LED was on. So then you know the LED is in the right direction. Once we have that connected and working, again, and we're pulling power from this strip, this kind of gutter alley here that's all connected. And again, remember in your stuff, these pins over here are connected, and the pins, like these blue pins, the 5 vertical pins, are also connected here. So again, once you have that done, we're going to move this. We're going to do some programming in Python, and eventually we're going to move this pin so that it doesn't get power all the time, but it gets power from this GPIO pin and do that. So again, first step is just to get back to this circuit from last week where the LED is on all the time. So we've got to process some issues here, and then we'll try to get to see if you can get that far, and we'll move you through the next steps there. Okay, let me pause this. So, okay, I'm going to go around and check, see how we're doing, make sure we're at the first circuit, and then we're going to talk about, so hopefully you've got the first circuit done. If not, call either Heba or I over, and then we're going to start B in just when everyone's ready for that. Okay, I'm going to walk you through the next part B here. For this, we're going to do some simple Python programming here because that's the language we're going to use to control the Raspberry Pi a lot. and it's built into or it's pre-installed in the Raspberry Pi. Now, I need to run Zoom and record this, so I actually have my Raspberry Pi in a window here for this. So this is a view of my Raspberry Pi, but it's just in a window in here. So that's why. And again, later on, you'll learn how to do this too, but so it just helps me with the recording. And so the graphics are be a little laggy because it's running this in a window. So I'm going to go up to the Raspberry in the upper left-hand corner, that menu, and I'm going to click, oops, I lost my mouse again here. There, okay, I got my mouse back. Okay, I'm going to go to the Raspberry, go to programming, and we're going to run something called Thonny. It's a Python compiler, Thonno. Oh, Thonny. So run that, and it should open it up in a little window here for us. And yours will probably start off blank. So I'm going to do a new one so it looks like yours. Now with Python, we can write a program in the top half here, or we can execute commands directly in the bottom half. So to just try this out, I can go into the bottom half and I can just type in a command, an expression like 2 + 9, and it will calculate that and show that. Let me see if I can make this window just a little bit bigger. I'm going to resize this window, I think, so maybe you can see it all there. Okay, that's better. So we can type in expressions in the bottom. I think those are just temporary. We can also have a variable. We can say like x, oops, let me go, x = 8. And then I can say like print x. When I say some commands like print, I put in the command and I have to do a parenthesis and then an expression inside parentheses and close that parentheses. So I say print parenthesis x. I can also say things like print parentheses x. If I put something in quotes, it prints it out. So like if I want to print hello, I would say print parenthesis, and in quotes, I would say hello there. But if I want to print out or use a variable, I would just say like print, oops, keyboard got stuff. Print, if I say print x or print, if I said print hello without quotes, it's going to look for a variable called hello. And it'll tell me that variable is undefined here. So you can try some of that stuff here. And then we're going to try to do our first Python program, and that'll be up here. So if you don't have an untitled or empty program, hit new, and you'll get an untitled one. And then line 1, we're just going to say print, oops, print parenthesis, quote, getting some issues with this quote, hello, world, quote, here. Hello world is the classic first program we write in almost every language out there. So once you have that, you can hit run, click on the run key, it'll run the command and it'll do that. So whatever you type up here, it'll print that out directly down here. If I misspell something up here, it'll misspell it down here also. So see if you can get this Thonny window open. Again, Raspberry Pi, program Thonny, try out some stuff right in the shell, and then make sure you have an empty or new program here and print out hello world. And then you can kind of work through some of these other things, try a different program here also. And we'll come around and help, see how you're doing. Okay, once you practice some with writing some Python code, and again, if you have the lab up, you can actually just copy this code and like paste it over here and do stuff like that, and then try to run it. So that'll be part B. And we'll want you to save your Python code and to do it. Now, how do you, or submit a picture of it? How do you save your Python code here? So right now it's untitled. I'm going to hit save and then give it some name. I'm going to make my screen a little bigger here, it looks like. So, okay. Let's see if I can make this. Okay. So I'm going to give it some name here and saving it in my documents folder by default, I think. So again, I can call it like lab 3B and then hit enter. And it will add the Python extension here. It says Python files usually have a .py extension. Do you mean lab3b.py? And you want to say yes. If you just add the py itself, that's fine. But we want to, it should be a Python file there. So I'm going to hit that for this. So that should save the file here. Now, if eventually you're probably going to want to do this all on your Raspberry Pi and submit it all on the Raspberry Pi. Some of the Raspberry Pis are old and very slow. So you have to decide, you can submit this file. You can also just take a picture of it if that's easier. So you can just grab your phone, take a picture of that screen and submit that. Or you can also do a screen capture. But again, depending on where you're working and stuff, some people like, I've seen some students just do the whole lab on their phone, ready to submit and stuff. So you can try that too. You can decide. So somehow we just want to have a Python program like this, preferably the last 3B. We just need one for part B. We just need one of your Python programs submitted, preferably the third one, but I don't think Heba will take off points if you submit like the second one. She gets pretty mean sometimes, so you'll have to see. She says she's not mean, but we understand. So submit one of your Python programs here. Now, for part C, we're going to try to program our LED to turn on and off with a Python program. So we're going to take this Python program here. I'm just going to copy it. I'm going to do a new Python program here and paste that in here. So I pasted the whole Python program here, import the libraries, create the LED. So, and then notice we say LED is on pin 21. That'll be important. And then we're going to turn the LED on. We're going to turn the LED on. We're going to sleep for half a second, and then we're going to turn the LED off. And the command is led.off. parenthesis, and then we're going to turn the LED off, and then we're going to sleep for another half a second, and we're going to do that again and again. So it should go on, off when we run this.
So do you need to make like this circuit
right
on pin 21?
Right. Okay. So then, but to get that to work, so we've got that working. But now if I run this here, my light will not blink. It's going. So what we have to do is we've got to go to pin 21 here and do our power. Instead of pulling it over here, we have to pull it from this point. So let me see. Let me stop sharing and see. So here's my pin here. Here's my power cable. Is this red cable? And I'm going to go over to pin 21 here, and I'm going to plug in the power cable right into pin 21, which is the last pin generally in that thing. So now I've moved this from the power strip or area over here to pin 21. Then if I run my program, let's see if I can keep this up here. If I run my program, the light should go on twice. There. So I run the program, it should go on twice so you can see it blinking. If you can get your program, if you can get that working, you're basically done for it. That's our goal today. Well, we'll try to put in a button. Okay, we'll try to put in a button. One more thing, but that's a big, if you can program that. And again, if you want, you can try programming it, changing the program a little bit so it turns it on and off more times for longer times or whatever, but see if you get that. So again, copy the code over. Oops, let's share that again. Where's my screen share? Where's my? So again, copy this whole, oops, that's the wrong lab 3. Copy this whole program over into a new program and then wire up your circuit so it works like that. And we'll come around and help you. There's some confusing about when I say pin 21, which one I mean here. And what we want to do is look at our little T adapter here, and it'll have little numbers on it. And not everyone will be numbered often, but a lot of them will be. And 21 is the last one on mine, is the last one on the pin here. That's what I want. Now, your breadboard might also have pin numbers on it. We are going to ignore those because depending on where you have this plugged in, it might vary. In fact, mine is in like pin 46 here. So I want to read the pin number here on my T adapter. I don't even know if you can see that there, but that's what I'm reading is the pin number on the T adapter. Make sure this is plugged into that pin there because, and again, we're using 21 and then in our code, we're putting in 21. If we were to use another pin, we put that pin number here. Okay, so see if that helps. Okay, the last part of this is to add a button that you control from your program. So we're going to put in a little button here, and we're going to wire that into a ground, and then pin, I don't know what pin that is, pin 26 there. So we're going to do this little circuit here. So I'm going to let me stop sharing so I can see that, but I'll wire that circuit up here. So again, I'm going to put in my button here in anywhere, just so it's in 2 locations. I'm going to pay attention to where the pins are going in here. I'm going to move that a little bit over here so I have some room. And I'm going to take a wire that'll go to ground. So ground is in this last slot. I'm going to wire that up to one side of the button. And I'm going to get another button that goes into pin 26, which is the pin right next to ground. So ground and pin 26 are right next to each other on that side. And do that to the other side of the button. Something like that. And now I'm going to take the code. Let me share again. Let me do so now that I have my this circuit wired up here, I'm going to take this new code here and copy that. I'm going to make a new program and paste that in here. And again, so we import 2 libraries, the LED library and the button library. We create an LED variable on pin 21 and we create a button variable on pin 26. And then we have this loop while true, and it's just going to sit here and loop forever, and it's going to keep checking if button is pressed, and that's our button, it's in 26. Then we say press, button is pressed, and we turn the LED on. Otherwise, the LED is off here. So now if I run this, and if I push my button, it should tell me that it's on and off, and it's not. Oh, I didn't actually run it. Okay, now if I run this and I push my button, it should say, but it'll say button pressed a lot, and the LED should come on. When I let go of the button, it might say button is pressed for a while, but it should eventually stop. It doesn't. It prints out a lot when we push the button, especially if you should just push the button for a while. So see if you can get that to work there. So that's part D of this. Part E is just if you have time. So I'm going to make this optional actually. if you have time, see if you can change one of these programs here. See if you can change the program so it blinks a certain number of times or does something else. So look back at these programs and see if you can make some modification to one of the programs. Again, we're not teaching you Python yet, so it might be a little hard. So that's why this is optional. So if you get everything working and you want to try just adjusting one. I know one of you, we had one of the pins wasn't working, so we changed the LED from pin 21 to pin 16. So another thing you could try is just if you plug this into a different pin number, can you get this to work also? And again, a couple ways to turn this in. One is if you have a phone, you can just take pictures of everything as you go along, and then when you're done, just submit a document with the pictures in it there. If you want to attach the Python files, you can. Again, sometimes I find students they find it easier just take a picture of the Python file here. It is kind of nice to save these Python files as you go. So when you get to these, if you hit save and give them some names, so like this is going to be lab 3d.py and save those for this, because later on you might want to look back at these and tweak them. Okay, I think we're good. So again, if you get done with that, you're done for the day. Share.